In this part of the video, I will show you how to graph a quadratic function in trinomial form. Trinomial form is y equals ax squared plus bx plus c. Sometimes we call trinomial form standard form. How do you graph a quadratic function in trinomial form? Well, step number 1, you have to identify the vertex. Step number 2, you're going to use the scale factor. Step number 3, use the axis of symmetry. Step number 4, use the y-intercept. To find the vertex, the formula is x equals negative b over 2a. And once you get a number for your x coordinate, you're going to take that number and plug it back into y. By plugging that number back into y and evaluating, you'll end up with your y coordinate. In example number 1, we want to graph y equals x squared plus 4x plus 5. This can get really complicated, so just to make sure you follow the steps. Step number 1, find the vertex. So the formula for the vertex, in case you forgot, is negative b over 2a, comma y equals f of x. So we need our x coordinate and our y coordinate. To find our x coordinate, we're using x equals negative b over 2a. So let's go ahead and label our a, b, and c values so that we can plug them into our formula. In the problem, a is 1, since there's no number in front of the x squared. B is 4, and c is 5. A is 1, b is positive 4, c is positive 5. Take those numbers and plug them in. Negative b, which is 4, divided by 2 times a, which is 1. Negative 4, that's negative 4 divided by 2 times 1 is 2. Negative 4 divided by 2 is negative 2. So now we know that the x coordinate of our vertex is at negative 2. Now we need to find our y coordinate. To find the y coordinate, we're going to take our x value and plug it into our function. Our function is y is equal to x squared plus 4x plus 5. So take that x value and plug it into wherever you see an x. We have y is equal to negative 2 squared plus 4 times negative 2 plus 5. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 5. So 4 minus 8 is negative 4, and negative 4 plus 5 is 1. So the y coordinate of our vertex is at 1. So the vertex is negative 2, comma 1. Now let's plot it. Negative 2, comma 1. Label it vertex. And as we know, our axis of symmetry will also fall on top of our vertex. So go ahead and draw your axis of symmetry. The axis of symmetry is at x equals negative 2. Okay, so now that we've labeled that, let's go ahead and identify our scale factor. Step number 2, the scale factor. Our scale factor is our a value, and a is 1, which means that the parabola opens up and is of regular size. So from the vertex, we want to go 1 unit to the right and 1 unit up. And it's always 1 unit to the right. We went 1 unit up because A is 1. And if we have a point on the right side of our axis of symmetry, we're automatically going to have a point on the left side of our axis of symmetry. For step number 3, that was the axis of symmetry, which we already completed. Now let's move on to step number 4. So step 3, axis of symmetry. Step 4, let's use the y-intercept. If we look at our equation, y equals x squared plus 4x plus 5, the y-intercept is always going to be the last number, the constant, in our equation. And the reason being is because if you were to replace the x's with zeros, because that's what a y-intercept is when x equals 0, you'll end up with just your c value. For example, 0 squared is 0, plus 4 times 0, which is 0, and 0 plus 5 is 5. So the y-intercept is 5. Once again, to make it easier, your y-intercept is always going to be c. Let's plot our y-intercept. Our y-intercept is 2 units away from the axis of symmetry, which means that we also have a point that's 2 units on the left side of our axis of symmetry. Now that we have all 5 points, let's draw our parabola. Highlight it. Let's find the minimum. Our minimum y value is 1. The domain will be all real numbers. So now let's look at example 2. Graph y equals negative 1/2 x squared plus 4x minus 6. Let's start by identifying A, B, and C. A, B, C. Now let's find the vertex. And I want to write out the formula. It's x equals negative b over 2a, comma, y equals f of x. Let's start by finding the x coordinate. So x equals negative b divided by 2 times a. Our b value is 4, so that's negative 4 divided by 2 times negative 1/2, which is going to give us negative 4 divided by 2 times negative 1/2. Well, the 2's will cancel out, and it'll leave us with just negative 1. Negative 4 divided by negative 1 is positive 4. So the x coordinate of my vertex is positive 4. So remember, we need an x and y coordinate. Now that we have our x coordinate, let's find our y coordinate. For the y coordinate, we're going to take our x value and just plug it back into our function. Y equals negative 1/2 x squared plus 4x minus 6. Take the 4, plug it into x. That's negative 1/2 times 4 squared plus 4 times 4 minus 6, which is negative 1/2 times 4 squared is 16 plus 4 times 4 is 16 minus 6. Negative 1/2 times 16 is negative 8 plus 16 minus 6. Negative 8 plus 16 is 8. Minus 6, which is 2. So the y coordinate of our vertex is at 2. So now let's graph our vertex, which is at 4, 2. Label it. And once again, we know that our axis of symmetry is going to fall on our vertex. Label the axis of symmetry, and our axis of symmetry is at 4. Now let's use our scale factor. So moving on to step 2, our scale factor, that's our a value. A equals -1/2. I know two things. I know that the parabola opens down, and I know that my parabola is going to be wide because my a value is -1/2, and that number is between -1 to 1. With that in mind, let's go ahead and use our scale factor. So from the vertex, we want to go 1 unit to the right. And remember, it's always 1 unit to the right. So 1 to the right, and because it's a half, we want to go a half unit down. And if we have a point on the right side, we also have a point on the left side. So go ahead and draw its reflection. And since we've done step number 3, let's go ahead and move on to step 4, which is the y-intercept. So if I rewrite the equation, it's y equals -1/2 x squared plus 4x minus 6. Remember, the y-intercept is our c value. Remember, the y-intercept is our c value, which is -6. It's always c. Now we're going to plot our y-intercept on -6, and our y-intercept is 4 units away from the axis of symmetry, which means that its reflection will also be 4 units away at 8, -6. And now that we have all 5 points, let's draw our parabola. Highlight it. Our vertex is the highest point, so we know that we have a maximum. And our maximum y value is at 2. And the domain? Well, it's all real numbers. Let's move on to example 3. Graph y equals -2x squared minus 8x minus 10. Start off by labeling A, B, and C. A is -2, B is -8, and C is -10. Include those negatives. Step number 1, let's find the vertex. And the formula is x equals -b over 2a, comma y equals f of x. Start off with the x coordinate. X equals -8. So b is -8. So -8 divided by 2 times a, which is -2. Class, a negative times a negative is a positive, so that's going to be +8 over 2 times -2 is -4. 8 divided by -4 is -2. So the x coordinate of my vertex is at -2. Now let's find the y coordinate. For the y coordinate, we're going to take our x value and plug it into our function. Take the -2 and plug it into your x values. That's going to give us y equals -2 times -2 squared minus 8 times -2 minus 10, which is -2 Negative 2 squared is 4. Negative 8 times negative 2 is positive 16, minus 10. Negative 2 times 4 is negative 8, plus 16, minus 10. Negative 8 plus 16 is 8, and 8 minus 10 is negative 2. So the y-coordinate of our vertex is negative 2. Now that we have our vertex, let's plot our point at negative 2, comma, negative 2. Label. And let's draw our axis of symmetry. Our axis of symmetry is at x equals negative 2. Moving on, step number 2. We need our scale factor. Our scale factor is a and a equals negative 2. So we know that the parabola opens down and is narrow. Okay, let's use our scale factor. From the vertex, let's go 1 unit to the right. And remember, a is negative 2, which means that we're going down. So go 1 to the right, 2 units down. And go ahead and draw its reflection by going 1 to the left, 2 units down. Step 3 we did earlier. Let's move on to step 4. Step 4 is identifying the y-intercept. So rewrite the problem. And identify the y-intercept. The y-intercept is just the c value. And that's negative 10. Let's plot it. And since our y-intercept is 2 units away from our axis of symmetry, we know that its reflection will also be 2 units away. Okay, now we want to graph the parabola. Highlight it. And then let's go ahead and identify our maximum. Since our vertex is the highest point, we have a maximum at y equals negative 2. And the domain, that's all real numbers.